Ay! 10:32 na mo. Hindi pa-agets ng chain rule lane. Hirap ng chain rule talaga, no? Tawagin ko nga si si Joseph. Talagang Joseph. Joseph? Kalambak na sagot. Mag-review siguro yun. Ay na, ayun. Manahan pa.
Ikaw na rin, Pascal.
Alike pa par, tan chain rule ka sakit. Kakagising ko pa. Kakagising ko pa kanya, may kasakit. Wow, pinabeta pa YouTube. Wow. So, itang i-reach ka. Wow. I-reach pala no rin yun. Ngayon na. Sige, turutan mo. Sige, soy. Sige, soy. Good luck. Sige.
So today we're going to tackle the topic of derivatives of algebraic functions. In getting the derivatives of simple algebraic functions, simply multiply the exponent to the variable raised to the power of the exponent reduced by 1. So that looks like nx raised to n reduced by 1. It's as simple as that, but let's give some examples. So for example, if you want to get the derivative of x cubed, you bring 3 down as its constant. So 3x raised to 3 reduced by 1. Therefore 3x squared is the derivative of x cubed. Product rule and quotient rule. So these two are very similar to each other, so I'm just going to simplify things so you don't get them mixed up. So this is essentially the formula of the product rule. So it's the first expression multiplied by the derivative of the second expression added to the second expression multiplied by the first expression's derivative. So let's give some examples. For example, if we have here 2x squared plus 6x multiplied by 2x cubed plus 5x squared, we can simply first place the first expression multiplied by the derivative of the second expression, which would become 6x squared plus 10x, added to 2x squared plus 5x squared, which is the second expression, multiplied to the derivative of the first expression, which becomes 4x plus 6. So we just simplify things, and here we have our final answer. There's no more simplifying to be done, it's just as it is. And next, in quotient rule, it's very similar, as you can see here, but we were just mixing things up a bit. So the order is a little bit jumbled. So we get the second expression multiplied by the derivative of the first expression minus the first expression multiplied by the second expression's derivative over the second expression squared. So if we have an example here, 2x cubed over 4 minus x, we can simply apply the formula here and simplify things until we are left with this. And this essentially becomes the derivative of your quotient. The derivatives of exponential functions. So there are two types. A is natural. So that's one we'll discuss first. So the general form of natural is d over dx equivalent e raised to x. So you can notice that nothing actually changed in the equation. It is the unique exponential function equal to its own derivative. The natural logarithm, or logarithm to base e, is the inverse function to the natural exponential function. So that's why it remains as it was. So next is general. So here is the form of general. There you go. So in this case, the derivative of an exponential function with a whole number as the base is the actual given multiplied by the natural logarithm, aka ln, by the natural logarithm of the base. So that is why this is the general form. So that is exponential functions. The chain rule. Let's write that down. So what's chain rule? In general, it is expressed as f of g of x as f prime of g of x multiplied by g prime of x. In other words, it helps us differentiate composite functions, more complex things. So let's give an example so we can further understand. Let's give, for example, sine x squared. Okay, so what we're going to do is we're going to apply the power rule. For those that don't remember the power rule is nx raised to n reduced by 1. So let's here we go. So secondly, we can get the derivative of the inside function. So the inside function, sine x, is equal to cosine x. So if we merge those together, it would then look like 2 sine x raised to 2 reduced by 1. Multiplied by the derivative of our inside function.